Good evening once again. Welcome to today's session. Last session we ended at steps in solving hypotheses. So we learned that you have 4 steps in doing so. So first of all, you formulate your null and alternate hypothesis. And I'm sure as at now all of you know how to do that. The second step is you calculate the test statistics. You get it? So that is the T or C. But I said in research methods, you are going to use T test. That is when n is what? Small. That is if n is less than 30. That's when you are going to use the T. And I hope by now you know the formula. T is equal to sample mean minus population mean all over x. That's the standard deviation over square root of what? M. So that's the test statistic. Then we move on to step 3. Step 3, you determine your p-value. The p-value of the test statistic. So the second, you determine the p-value of the second step. That's your test statistic. Then you use that to take your make a decision and conclude. And making a decision and concluding, we have 2 approaches. We have the critical approach and p-value approach. So when you look on the screen, you see that you use Z if sample is large. So how large is your large? So my large is large if n is greater than or equal to 30. And n is small when and sample is small when n is less than 30. So we determine the degrees of freedom by subtracting 1 from the n. And this is how we determine the critical value. So it is the alpha, then you match it with the degrees of freedom. All right. So let's move on. So this is the p-value approach. You use the T calculated, that is the T test, or the Z calculated. But under research method, you are going to use the T. Most of them will be the T to compute the p-value. And I gave you these rules. Because so under the critical value, we learned that we must reject HO if T computed or calculated is greater than T critical. Otherwise, fail to reject. And the p-value is the opposite of the critical value approach. The p-value approach is the opposite of critical value approach. We also learned that under p-value approach, we reject HO if p-value is less than alpha. Otherwise, fail to reject. Now, when you use any of these method approaches, you must get the same conclusion or the same decision, the same answer. Though they are opposite, but when you use p-value, you must get the same decision when you use critical value approach. Then lastly, you conclude there is enough evidence to so you get it. So these are the 4 steps to follow when solving hypothesis. Okay. So before we move on to solve applied examples, I'd like us to look at certain tutorial sets for formulating the null and hypothesis, null and alternative hypothesis. So let me share this for that. Okay, so can you see the questions? You are going to read.
Yes, please.
You are going to read and answer it. So part A, formulating the hypothesis. Formulate the null and alternative hypothesis for the following statement. So someone should read. And I do for read.
So the state lottery also claims that the average household income of those people playing the lottery is at least $37,000.
Okay, so before we move on, I gave you some English words the other time we met. That's the last session. We learned that when you see something like at least, at most, above, below, it's not different from, you get it, was, is, of, performs, within. above, below, exceed, younger than, more than, less than, different from. We know what these words means. You get it? And in this scenario, on the first question, we are seeing a certain word. Who can tell me that word?
Average.
How do you determine? We know the average. We are talking about average because all of them are talking about the population parameter. But how do you know that this one will be null, this one will be alternate? So we are seeing a particular word there, which will give us a certain sign, and then that sign will help us know whether this one will be the HO or the HA. So we can pinpoint that one.
Okay, to my understanding, for you to determine the null hypothesis and the alternate hypothesis, with the null hypothesis, it includes less than or equals to or greater than or equals to. But with the alternate hypothesis, it does not include less than or equals to or greater than or equals to.
Okay. So in this case, the 37,000, the at least is saying what?
The
at least is greater than or equals to.
Okay. So which one is that? Is it null or alternate?
I'll go for now. Yeah, now alternative. Sorry, now hypothesis.
Yes, because the at least we are saying that it's what? Greater than or equal to. So the least. So first of all, HO is such that mu is greater than or equal to 37,000. And your HA will definitely challenge what? The status quo. So your HA is such that population mu or the mu is what? If this one is greater than or equal to,
it's less
then
than.
that means the alternate will be less than 37,000. That's the mu will be less than 37,000.
Okay, so let's move on to number 2.
Can you hear me?
Yes, you can hear you, Charlie.
Okay, so the marketing department for a hand calculator claims the battery pack performs 20,000 calculations before it has to be recharged.
Okay, so who can tell me the exact word here? The exact word, I just mentioned them. So I mentioned performs. You get performs. Now, when you are reading and you see performs, it is saying just it is giving you clue to what? Equal to sign. So here they are saying performs 20,000 calculation before it has to be recharged. So here your HO, so the performance is talking about the null hypothesis, okay? And it will be HO is such that mu is equal to what? 20,000. And HA is such that mu is what? Not equal to 20,000. So with this one, we have equal to. So are we talking about one field test or two field tests? Hey, network. Okay, so Nana, I think his network is not working. Can you help us?
Can you hear me now?
Yeah, I can hear you.
I said it is a two-tail test.
Two-tail test, good. And with the first one, because it's greater than or equal to, is what? One-tail test. So apart from equal to sign and not equal to sign, the rest are what? One-tail test. All right. So let's move on to the 3. A pharmaceutical manufacturer is concerned that the mean impurity concentration in pills should not exceed 3%. Should not exceed 3%. So if you are saying should not exceed. So which sign are you thinking of?
So you use the less than or equal to sign.
Use what?
The less than or equal to sign. So less than is less than or equal to.
Less than or equal to good. So HO is such that mu is less than or equal to 3%. That is 0.03. And your HA will challenges the one, the HO. So HA is such that mu is greater than 3%. Okay. So let's move on to question 4. A company selling new econometrics computer software advertises that firms using this software obtain, on average, during the first year, a yield of not at least 10% on their initial investment. Now, just for if you are formulating the hypothesis, ignore the not. Good, right? So focus on the at least. So the word here that you must focus on is what, the at least 10%. And we know that from Quanti, we know that under linear program, at least is what, greater than or equal to. So here, this at least 10% is talking about the null hypothesis. And because it's greater than or equal to, is what, one field test. So your HO is such that mu is greater than or equal to 10%. HA is such that mu is what? Less than 10%. I hope you get what you have been saying.
Yes,
Yes,
please.
please.
Okay, good. So 5. A professional rock climber claims that he can climb a particular mountain within half an hour. Half an hour is what, 30 minutes, right?
Yes.
Okay, so they are saying we have this rock climber, professional one, and he claims that he can climb a particular mountain within half an hour. So who can tell me the exact word here that relates to a particular sign? Hello.
Yes, we are listening.
I just asked a question. I'm saying who can give
Please come
me,
again.
looking at question 5, who can give me the exact sign?
Ampere
Okay.
equal to sign. Equal to.
Eh? He said,
Okay.
hello.
I'll go for hi.
Come again.
I'll go for less than an hour.
Less than an hour.
Because the question was a professional rock climber claims that he can climb. That means he's now going to climb a particular mountain. So I will choose for like he's now going to. So that means he hasn't done it. So it's less than. I'll choose less than or equal to. Less than or equal to an hour.
Any idea from Nana? Do you have any idea? Hello. Any idea before I come to it? Who is talking? Okay, so therefore you got it right, but I didn't add one thing. So I mentioned this earlier, even earlier this class. I said within is less than or equal to, because within it can be, if it's within 30 minutes, it can be 1 minute, 2 minutes, within half an hour. So it means the maximum that climber can spend, the number of time, the maximum time can spend on climbing that particular mountain is what? 30 minutes. So it can be 30 minutes and below. So that 30 minutes is passed. So it's less than or equal to 30 minutes.
Okay.
Yes. So if you are saying it's less than, it means 30 minutes is not part. So it should be 29 minutes and below. But this one, they are saying within half an hour. So it means you can use 0 to 30 minutes. Any minute that fall within this range, you can use that. You get it?
Yes, sir.
All right. So this one, the H is such that mu is less than or equal to 30 minutes, and your
30
HA
minutes.
is such that your mu is what? Greater than 30 minutes. It's always
Greater
challenging
than
the
30
status quo.
minutes.
All right. So let's look at the 6. The manufacturer of a new product claims that his product will increase output per machine by at least 38 units per an hour. Yes. Any answer? We have the word there. We meant it like 3 times.
So it's the okay. The mu is greater than or equals to 38.
Okay, so if it is greater than or equal to 30, is it talking about
that's the null hypothesis.
Exactly. Good.
And the alternate hypothesis is mu is less than the 38.
Exactly. So that's all. All right. So let's move on to today's class. Okay, so this slide is giving us the decision rule. So we are saying that always reject the HO if the calculated or test statistic is what? Greater than the tabulated or critical value. So this is talking about the critical value approach. You get it? This implies rejecting HO when the P value is less than the alpha. And this one is talking about what? The rule for alpha. So these are the rules or the decision rule that you use to make conclusion. And this the T table. This is the T table. You see, last semester we met some tables. We met Z, T, I think F2 was part and stuff. But with this particular one, there's slight change. You see, we have 1 tail and 2 tails. So if you are solving a question, you see quantity last semester, quantitative method. When you have alpha to be 5%, and after formulating your hypothesis, you get it to be 2 tilted. That's when the null is equal to an alternate swap not equal to. You have to divide the alpha by 2 because it's 2 tilted. Now, if you are using this T table here on the screen, you're not going to divide anything by 2. If alpha is 5% and you are getting, after formulating your hypothesis, you get 2 tilted. Leave it like that. When you come to the table, you see 2 tilted here. You get it. You are seeing 2 tails. So we shouldn't divide. You shouldn't divide anything by 2 if only you want to use this particular table. So we'll come to this table. We will be using this table for our work, for our p-values, and for our test statistics. You get?
Yes, please.
Sir.
Okay. So we are saying always use the T calculated to get the p-value for the test statistic, and use the degrees of freedom to find the T tabulated. So we come to this table, we know how to use it. So let's take first example here. Go to the whiteboard to solve. So the first example, you'll be solving 3 questions, then done for the day. All right, so someone should read it for us. Hello. Someone should read. Like,
So suppose that you are thinking of taking over an SME. The current owner claims the weekly turnover of each existing SME is not different from 5,000 Ghana cedis. And at this level, you are willing to take on the SME. You would be more cautious if the turnover is below this.
figure. I don't know why
Okay,
the
this. You examine the books of 26 SMEs chosen at random, and that the average turnover was 4,900 cedis with a standard deviation of 280 Ghana cedis.
Okay. And find that. Okay. So it's fine. I don't know why the F and I are not showing. Okay.
Hello.
Okay. So what will you do? I'm asking you if you are the new owner to take over. What will you do?
While going by the given information, like I'll reject this opportunity because I don't think I'll be making enough turnover. I think I'll be running at a loss.
Because they are saying the average turnover was 4,900.
Yes.
But you know, sometimes that's when we applied the hypothesis. You get it? So at times you don't have to look at the figures and make your conclusion. You should not jump into conclusion. I think critical thinking. I'm forgetting the topic. Okay, back for talk. Your hand is up.
Okay. To my understanding, they've given us the mu, standard deviation, the sample, and everything that we need to use to test for the hypothesis. So, in order for us to determine that what the person is thinking is right or not, we have to we have to test for this before we know that we are going to reject or we are going to fail to reject.
Okay. Thank you. So that's why we have this topic. All right. So here we will follow the 4 steps in solving hypothesis. First of all, you formulate your null and alternate hypothesis. You get it. So with this one, who can formulate the hypothesis for me?
Can you hear me?
Yes, I can hear you both.
Okay, so HO is when mu is equal
so I'll be using you. Okay, hello. I'll be using you for my mu because I cannot be writing this that. All right.
It's equal to 5,000.
So our HO is such that mu is equal to 5,000. Why are you saying 5,000 equal to 5,000?
Because they said it's not different from.
Yes, that's the English word. It's not different from that. So it's equal to. So the HA surely challenges what the HO. So this one will be the opposite. Not equal to. Okay. So this is the critical part. The first step is the critical part. So when you get the first step, you are good to go. So what the second step? The second step is saying we should compute for our test statistics. And I said under research methods, most of the testing will be under T test because that one, our N is not greater than 30. Mostly our N is less than 30, less than 30, less than 30. So with this question, he said you examine the books of 26 SMEs chosen at random. It means the sample size is 26, which is less than 30. So you are going to use what? T statistic. So the T is given by T and sub, I think, N minus 1. N minus 1. Then rho is what? Our sample mean minus population mean all over what? X over what? Square root of
Square
N.
root of N.
Okay. Okay, so this is the formula. And sorry, we have to list our parameters before we even start solving. Sorry for that. So let's list them. Use 5,000 S bar, which is the sample mean. What?
4,900.
4,900. Okay, then
Our
standard
deviation
280.
is 280.
What again? N is what?
And our N
26.
is 26.
We need they omitted one particular thing. Who can tell me that? We need something here, and they didn't bring it in the question.
I think the sample standard deviation or
sample standard deviation. You are going to use the standard deviation given.
okay. So I think it's the critical value, that is the alpha.
Alpha, the level of significance. So we are saying that by default, when alpha is not given, use what? 5%. When alpha is not given, use 5%. You get it?
Yeah.
Okay, so we have our something here. So we are going to solve for T calculated, right? T calculated is equal to S bar is what? Sample mean 4,900 minus the population mean 5,000 all over X, that is 280 all over what? Square root of N 26. So please punch it on calculator and give me the answer. Okay.
So you get negative 1.82.
So you are saying we are going to get what? Negative
1.82.
Okay, so these are T calculated, right? T calculated. So what is the next thing to do? Next thing to do.
You find the
T critical.
Yeah, that's the degree of freedom.
So the T critical,
ability.
we are saying that we are going to use the degrees of freedom and the what? Comma and the alpha value. Then we find that on the table. You get it?
Yeah.
We are saying that degrees of freedom is equal to what? N minus 1. So our N is 26. Subtract 1 from it, you get 25. And the alpha, we are saying 5%, which is 0.05. And I'm saying, don't say that this sign is equal to, so it's 2 tilt test. Can you hear me? Hello? Can you hear me?
Hi. Yeah.
Can you hear me?
Yes, we can hear you.
Yes. Don't say that because this hypothesis is 2 tilt test, so we are going to divide the alpha by 2. No. Maintain it as it is because we are having 2 tilt test answers on the table. So you are going to search for 25, 0.05. And you, wherever they meet, you choose that one as what their critical value. So let's move on to the slide and visit the table. Can you see the table now? Can you see the table?
No.
Nana,
Yeah, you can see the table now.
Okay. So 25 is the degrees of freedom, which is this side, and the alpha value is on top here. You get it. Degrees of freedom, alpha value. Okay. So degrees of freedom
1.708.
25, and the alpha is what? Alpha, where are you looking at? 25 is here. And 0.05 is here. It's this one.
So what about the one before that 0.025? We have 0.05 on top.
This one is 1 till. You have to look at this side. That's why I said we have answers for 1 till and 2 till.
Okay.
You get it? So this one is 2 till. That's why I said don't divide the alpha by 2 when you are going to use this particular table.
Okay.
You get it? So it's what? 2 plus or minus 2.060, right?
Yeah.
So 2. So the critical value is what? 2.060. Now, with the third step, you are going to make decision and conclude. The conclusion will be the last step. So we are going to use all the 2 approaches. So first of all, let's look at the critical approach. Critical approach. Critical value. Approach. Right. Okay, so with the critical value approach, I gave you the decision rule. I said we are going to compare T calculated and what? T calculated and what? Hey, T calculated and what? T critical.
And T computed. Okay, the same as T computed. Okay.
No, the T computed is T calculated. Now, when you are comparing, this one, you see, we got a negative number. When you are comparing, use what? The absolute value. You don't need the negative. You need what? The positive. Only the positive side. So use absolute. So you add the lines there to indicate we are using the absolute. So this one is negative. But because we are using the absolute, we have it to be this. And the critical was what? 2.06, right? So which one is bigger than other?
The T critical is bigger than the calculated one.
So always focus on the T calculated. So the T critical calculated is what? Lesser than T critical. So what was the rule saying? I mean, the decision rule for critical value approach.
Can I come?
Yes. The critical value approach was saying that we should reject HO. That we should reject null hypothesis if the T calculated here is greater than our T critical. Otherwise, we fail to reject. And here is the case T calculated is not what greater than T critical. So it's T calculated less than T critical. right? So here, decision rule will be what? Decision rule. We fail to reject. You get it? We fail to reject. Reject HO. Since T calculated of 1.28 of absolute, you bring the absolute is less than T critical of 2.06 at 5% level of what significance. So you have to bring the absolute. You have to bring the absolute here. Now let's move on to the p-value approach. P-value approach. And with this one, you compare what? The p-value and the alpha value. They are all probabilities. And how do you get a p-value? I said it the other time that the p-value is the probability of what? The t calculated or t computed. So whatever you get as your computed value, you find the probability of that value on the table. And when you are looking at it on this table, this particular table, you might not get the exact figure. This 1.82. You might not get the exact probability to what? 1.82. So you find what the nearest number, the number which is what? Closer to this 1.82. Then use that to solve for the p-value. Then you come and compare that p-value you solve on the table with the alpha value 5% that you're having. And the rule is saying that reject HO if p-value is what? Less than alpha value. Otherwise, you fail to reject. You get that? Did you get that?
Yes, sir.
Okay, so as I said, p-value is the what? Probability of the test statistic. And the test statistic, we got answer to what? 1.82. It was negative, but I'm saying we take the absolute, so 1.82. So we go and look for 1.82 on the table. We trace the value for that. You get it? So we are going to trace the degrees of freedom and the what? The 1T or the 2T number up there. So this one, it was two-tailed test, right? So let's move. So let me share the screen. So we are going to search for 1.82. And as I said, you might not get the exact 1.82 there. So whatever you get, if it is closer to 1.82, you take it. So this one, 1.82, who can tell me where it was? You mentioned it under, let's say, these figures. We are going this way. If you see it mentioned this way, then we trace it to this part. We are going to look for that number and trace it upwards. We are looking for the t values here. So who can tell me which number here is closer to 1.82? Yes.
Please, are we using the one-tail test or the two-tail test?
Is that this one is two-tail? So
are we using the one-tail?
This one is two-tail test.
We are
so
using the
when you
two-tail.
trace,
Okay.
you trace it to me here. Oh, I just shoot the answer. Yes.
0.10 then.
Number which
then
is
10.
We are looking for 0, which is closer to 1.82. Come again, you said what?
So 10, I said 10 and 0.10.
Okay, so this 10. We are talking about 1.81, right?
Yeah.
Okay, so we can also choose 1.833. Okay, this one.
Okay.
Yes. But if you realize something, they are all under what? One particular 1.0 and 1.0. So we have this, or you can go for that. Okay. So this one is two-tailed test. So we are going for what? 0.1. So that's the p-value. 0.1.
Okay.
That's the p-value. That's the p-value. You get it? That will be a p-value. So you go and compare it with what? Yes, you compare it with what? Hello? Hello?
Hello.
You
Yeah.
compare it with what?
Our alpha. We are going to compare it with alpha.
Okay, so the number is 0.10. Let me move to the whiteboard. So the p-value is what? 0.10. And the alpha is what? 0.05. Don't divide it because it's two-tailed test. On the table, we are having two-tailed test and one tail. So don't divide the alpha to be 0.025. No. Leave it as it is if only you use the table under this research method. But if you use the table we used last semester, you have to divide it. And if you divide it, you are going to get the same thing. Right? So the rule for this p-value approach is reject HO if p-value is less than alpha value. And here, our p-value is what? Greater than. Instead of less than, it is what? Greater than. So this is otherwise. So we fail to reject. You get it? So this one too, we fail to reject. Since p-value of, okay, we know that p-value is what? Greater than alpha value. You get that?
Yeah.
So this one,
Yes.
HO was saying that mu is equal to 5,000 and HA is saying that mu is not equal to 5,000. And we are saying we should fail to reject what? HO. You get what I'm trying to say? Let me rewrite this one. So HO said that our mu is equal to what? 5,000. And the HA is saying that our mu is not equal to what? 5,000. And I said if you use both approaches, we've used the p-value approach and we use the critical value approach, and all of them we are arriving at the same answer. And they are saying we should reject what? Forgetting to add this one. They are saying we should reject HO since p-value is greater than alpha. You get it? Great. So what they are trying to say is that we should fail to reject HO. In other words, we should accept this null hypothesis. So this 5,000 is equal to the 4,900 they are talking about based on the test. You get it? So we are going to do the last part. That's the conclusion, the fourth and last part. Conclusion. Last but not least. So the conclusion will be, you understand the word so far?
Yes, please.
So this should be your conclusion. Okay, so 994 was saying that since we are saying it's 4,900 and stuff, the average something, the 4,900 power. The 4,900 was the sample mean. Since the sample mean is saying, according to the companies they went, it's saying it's 4,900, not 5,000. Nana just made the conclusion that you want not take over. What is not is different from the 5,000. But based on our test, I say you should fail to reject one, the HO. So here there's enough evidence to show that the weekly turnover of SME, small medium enterprise activity, is not different from 5,000. Therefore, the SMEs should be taken. So you are done. You are done solving for this particular hypothesis. So do you understand before we move to a different question?
Yeah, I understand.
Okay, so let's move on to the next question on the slide. And yeah. So you see the slide is saying nothing prevents you from buying the SME. You get that?
Yes, please.
So this one to do answer. We are going to solve for this to answer. I don't know why I do this there. F and I doesn't show. Okay, so someone should read it. I beg, boss, read it for me.
Okay, the Wufiasem, a tomato grower, has developed a new variety of tomato. He claimed that the average yield per plant is at least 4 kg of fruit. A gardening magazine tests this claim by growing some plants and measuring the yield, obtained 0.69 standard deviation. See below. Does this data support the Wufiasem's claim? Formulate a hypothesis. Use both the p-value and the critical value approaches.
So the C below here is actually pointing or directing us to a particular table. Let me show that one here in the slide. Okay, so this is the table that they are talking about. So here, they didn't give us certain info. We need parameters to solve the work. They didn't give us some parameters here. So they didn't give us n, that's the sample size. So you look at this box, you see the n is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know n is 1, 10. So we have to solve for the sample. We have to solve for the sample mean. And we all know how to solve for mean, right? Summation of xi over n will give us. So you add all of these 3.6, 4.2, 3.8, 2.7, 4.0, 4.8, 2.7, 3.9, 4.2, 4.5. You add all of them divided by their number. The sample size is 10 divided by their sample size. Please, the sample size is not 5 because this box is different from this box. You see there are lines separating them. They are not together. So don't tell me that this 3.6 and 4.8 is 1. This is 2. This is 3. No. They are different boxes altogether. So it is 10. So it's 5 times 2, 10. Okay, so please solve that and give me the S bar.
Okay, I had 3.81.
3.81.
Yeah.
Add it again and divide it by 10.
The summation, the total is 38.1, and I divided it by 10, so I had 3.81.
I'm sure. We calculate. Let me do it. It shouldn't be 3.81.
Okay, it's 3.84 rather.
Yes, 3.84. Good. So here we
And I had
you
yeah,
get 38.4, then divide by 10, you get 3.84.
yeah.
So that one as what your S bar, that is sample mean. So now we know everything. Let's move on to the whiteboard. List our parameters and start solving the question. So we know the parameters to be. Okay, so let's list our parameters. So mu is what? Population mu is 4. The sample mean, that's the S bar, is what? 3.84. Hope you can hear me.
Yes, please.
And what again? What do you need again?
And
Sample mean,
standard deviation is 0.69.
so standard deviation. I think.
Alpha. And N.
So standard deviation is what? 0.69. Did they give us alpha? No.
No.
So default use 5%, which is 0.05.
Okay.
And N is what? 10. Okay, now let's move on to solve this. We know what to do. First, we formulate our null and alternative hypothesis and stuff. So first of all, so your HO is what? Formulate it for me. HA is what?
Okay, HO, that's our now hypothesis.
Hmm.
Mu is greater than or equals to 4.
Yes, because of the at least. Yes.
Yes, please. And the alternate hypothesis, mu is less than 4.
Okay. So we are done with the first part. Next one, we are going to find out the calculated or computed. So T calculated. We know the formula already. Go to our X bar minus mu all over standard deviation of X all over square root of N. So you substitute and do everything. Okay, so sample mean is what? 3.84 minus 4.
84.
All over what?
All over 0.69.
All over what? 10. Square root of 10.
Root of 10.
The denominator is the last one is square root of 10. So point and giving the answer.
I had negative 0.73.
Negative 0.
0.73.
Perfect. So these are T tests. Now we move on to find our T critical, right?
Yeah.
In T critical, we are seeing is the degrees of freedom and what? The alpha. And we are seeing the degrees of freedom is what? N minus 1. I'm not going to write this because I wrote it in the previous question.
Okay.
So degrees of freedom N minus 1. So 10 minus 1 will give us 9. Alpha is what? 0.05. We are going to use this thing here to look for our critical value from the table. Okay, so let's move on to the table. So we are going to look for this one, is it 1 tail or 2 tail?
It's 1 tail.
Yes. Good. So this one is 9. The degrees of freedom is 9. You match it with what?
0.05.
0.05. It's up here, 9 here. So we are getting 1.83. This one is not p-value, so don't think we are getting same as the first one. The first one, it was our p-value, that was one. That helped us to get to the 1.83. Okay. So critical value is 1.83. Our critical value is 1.83. And I said, with the T calculated, so here we are going to use, you are saying we should use both critical value and, because the same as what to the first one. Critical value, let's start with critical value. So with this one, we will solve for our heart. You compare T calculated and our T critical. So our T calculated. T critical. So T calculated is what? Is negative 0.73, but we are saying take the absolute 0.73. And this one is what? 1.83. Let me make it 1.83. And what's the rule under decision rule under critical value?
Another critical value. If the T calculated is greater than the T critical, we reject hypothesis. But if the T calculated is less than the T critical, we fail to reject.
So this one we want to be a decision rule. So this one T calculated is what? Less than what?
Less than T critical.
So our decision rule will be. So decision rule will be what?
Fail to reject.
So we fail to reject. Hence, T calculated. Absolute 0.73 is less than T critical of 5% level. Okay, so we are moving on to the p-value approach. So with the p-value approach, by now I know you know how to solve the p-value. P-value is the probability of what? The T, the test statistic. So really, p-value alpha. Okay. So p-value is what? So we know alpha to be 0.04. So we are going to use the 0.73 here to solve for our alpha. It's minus, but use the absolute to be 0.73. The 0.73. So let's move on to the slides. Good. So skim through and tell me the number which is closer to 0.73.
Okay.
Mm-hmm. 0.73.
Yeah, so I'm coming. Five and 0.25.
And so I want the value.
That's I said 5 and 0.25.
So 5 here and 0.25.
Yeah.
So this one, you are talking about this, right?
Yeah.
Yeah, so this one is closer to 0. So we only need this one, the vertical one. So this one is 1 till. So we look for the 1 till. This one 0.25.
Okay, 0.25.
Value. And what is normal decision rule for p-value?
Okay, with a decision rule for p-value, if the p-value is less than
if the p-value is less than the alpha,
alpha value, we reject HO. Sorry, reject hypothesis. But if
yes,
the
we reject
p-value
HO,
is,
that's correct.
Okay, we reject HO. But if the p-value is greater than the alpha, we fail to reject HO.
And in this case, p-value is greater than alpha. So what do we do?
We fail to reject.
We fail to reject HO. That one, I didn't bring HO. Since p-value is what? Greater than alpha.
Alpha.
Yes. We fail to reject HO. And then bring HO. Okay, so we move on to the last but not the least step. That one is what? Conclusion. So who can tell me the conclusion here?
Okay, okay, with the conclusion, the data given to us does not support the Wufiasem's claim.
Are you sure?
Yeah.
You are saying we should fail to reject.
Yeah, if we fail to reject, that means it doesn't support the claim that they are talking about.
Listen, if they are saying we fail to reject HO, meaning we don't say that way, but we have to say that way in this circumstance. So meaning we are accepting HO, and the HO is saying at least. So they support the claim. The test support the claim that the average yield per plant is at least 4 kilograms. Because the final decision for p-value approach, both p-value approach and critical value approach, is saying that we should fail to reject HO. And the HO is saying that our mu is what? Actually,
Greater than or equal to 4.
greater than or equal to what?
4.
So there is enough evidence that the average yield is at least 4%. So that should be our conclusion. You get it?
Yeah.
Okay, so we are done with this question as well. Any question before we move on to the last question for the day? Any question? So you
No
follow
question.
these 4 steps and the topic will become simple to you. Right, so let me go and copy the next question. Hey. Okay, so read this one first. Senior.
Okay. A shareholders group in lodging a protest claimed that the main tenure for the CEO was not below 9 years. A survey of companies reported in the Wall Street Journal found a sample mean tenure of 7.27 years for CEOs with a standard deviation of 6.38 years. The Wall Street Journal, January 2, 2007, and page 357, 28.
So here, shareholders group in lodging protest. So was not below 9 years. So which sign are we talking about?
Equal to sign.
Was not below. Was not below.
Was not below. That means it was above.
Yes.
So it's not below 9 years.
You are saying was
so that means it's greater than or equals to.
Yeah, greater than or equal to for the HO, and the HO is less than 9. Okay, so let's list our parameters. So our U is 9, right? Population mean.
Yes, please.
Sample mean is what?
Sample mean 7.27.
Okay, we know our parameters. So the first for HO is such that mu is greater than what? Greater than or equal to 9. HO
9.
HO is such that mu is what?
Less than 9.
9. Okay, so let's move on to find the T calculated. And by now the formula should be on your fingertips. So it's what? X bar minus population mean all over X over square root of n. And X bar is what? 7.727
7.27
minus 9. All over standard deviation is what? 6.38 all over square root of n.
root of 20.
I think
Negative.
they give us the alpha. What is the alpha?
It's not part of the question. No?
That's why.
And even this, the total, the sample, it's
I
not
think
in the question.
the question, the one I posted is not complete. Okay, I didn't put the full set.
Oh, okay.
How we can see it now?
Yeah.
So what to be the answer?
The answer is negative 1.21.
Negative
1.21.
Okay. So we are going to find our T critical. We are saying this one should also be at fingertips. Degrees of freedom now at the alpha. So this one, degrees of freedom is n minus 1. What is n? N is
N
20.
minus 1. So 20 minus 1.
So 19. Then comma. They give us alpha to 1%, 0.01. So you use this to track our critical value on in the slides. Okay, can you see the table?
Yeah.
Yeah, so we are looking for 19 and 0.01. This one is one till test. So 0.01.
Yeah, I can see the table again.
Can you see it now?
Okay. Yeah, I can see it now.
Yes. So this one is one till test. So looking at one till test, 0.01 is here, right?
Yeah.
Is this one. And degrees of freedom is 19. This one. Where did they meet?
So 2.539.
Yes, 2.539. Our critical is 2.539. Now we know this. So we are saying we should pass the statistical and practical conclusion using p-value approach and critical value. So this time let's start with the p-value. Okay, sorry. So we are starting with the p-value approach first. So with the p-value approach. So I think we know all of them. So what's our p-value?
We are now going to find it on the table. So it was 1.21.
Alpha value is 0.01. So we are taking the absolute value of p-value is the test that is. So we are going to use the absolute value of this, so 1.21, right? So we are going to look at 1.21, the closest number. One point two one. So 1.2, we are not getting 1.2 straight, right? So the closest number is 1.190 or 1.250. You get, and they are all under 1. This is one tail test. So
0.15.
So what's the decision rule for p-value?
With a decision rule, like I said earlier on, the p-value, if the p-value is less than the alpha, we reject. But if the p-value is greater than alpha, we fail to reject.
So we fail to reject. Hence p-value is greater than alpha value. Okay. Let's move to critical value approach. So this one T calculated, compared T calculated, the absolute figure of T calculated and what the T critical. The T actually would be 1.21. T critical was 2.53.
It was negative.
1.21.
It was negative 1.21.
Yes, but remember, always we take the absolute. We don't need the negative, we need the positive.
Okay.
So this one, T calculated is what? Less than what? T critical, right?
T critical.
And what's the decision under decision rule for critical?
We fail to reject HO if the T calculated is less than the T critical.
So we
reject HO if the T calculated is greater than the T critical.
Okay, so what will be our conclusion? So with the conclusion, we are saying that there is
enough evidence not below 9. Yes.
So we are done. And I hope with these 3 examples and we being familiar with the course, with this particular topic as well, we'll be able to do something. So next week, God willing, we'll meet and touch on the 2 population. This one is the single population or only one population. We are going to deal with 2 population as well. Okay, so we saw 3 examples. It is okay, which should be okay for us. And looking at the slides, it left with 2 practical examples. So I'll urge you all. Can you see the slides?
Yeah.
Yeah, so a travel magazine, and according to the label on packet. So this one, there are 2 examples I want you to solve it yourself. Then section 4, we are going to look at what? The sample population, 2 sample study. We are going to learn the 2 population. Right. Thank you for your time. And this is the end of lecture 3 So when you stand the two population to be lecture 4. Okay.
Okay.
So bye bye. Same time Monday. Bye bye.